All right, we're going to review adding and subtracting fractions before we get to the negative fractions. So first we have the fractions with like denominators, which we've already covered. When adding and subtracting fractions with like denominators, you'll add or subtract the numerators. You only add the top numbers. You keep the denominator or the bottom number the same, and then you always want to simplify. So this first example, the denominator is already 16. So it stays 16. We add 15 and 9, the two top numbers together, we get 24. And then we're going to simplify it or turn it into a mixed number first. It doesn't matter which. I'm going to divide these both by 8 just to make it smaller so that I can easily make a mixed number. 2 goes into 3 once with 1 left over. All right, subtracting with whole numbers, we'll subtract the fractions first. So I have 9 minus 3 is 6 over 10, and then 3 minus 1 is 2. I will divide the fraction top and bottom by 2, and that will give me 3/5. Now I've got unlike denominators. All right, this is the tougher part because you have to have common denominators. They have to be the same size pieces in order to put them together. So we're going to use common multiples or least common multiples to convert the fraction to have common denominators. So when you look at 5 and 4, you can either just multiply the numbers together. You can look at your multiplication chart and see where the least common denominator would be, which is the least common multiple. Sometimes multiplying them is the least, sometimes it's not. So in this case, 5 times 4 is 20, and 20 does happen to be the least common denominator. I prefer writing vertically because I like to have my fractions with the common denominators next to the other fractions. It makes it easier for me to change them. So we determined it was going to be a 20. We're going to times 4 on the top because I times 4 here. 3 times 4 is 12. To get 4 to 20, you times 5, so you have to times 5 on the top to keep them equal. I will add the two tops, that is 17 over 20. I will add 1 plus 3, which is 4, and that is in simplest form. Now I have 8/9 minus 5/6. So I need a common denominator for 9 and 6. If you can't think of one, you can always multiply them together, but that's going to give you a pretty big number that you would then have to reduce. So my 6s and 9s, what I usually do is I start counting by the larger number. 9, no, 6 doesn't go into it. 18, does 6 go into 18? Yes. So 18 is my least common denominator. The smaller the fraction, the numbers in the fraction, the better for me. Then we have to make an equivalent fraction. So 9 times 2 is 18. 8 times 2 is 16. 6 times 3 would give me 18. 5 times 3 will give me 15. I subtract the top numbers. The denominator stays the same. Whole numbers subtracted from a mixed number. So I've got whole numbers and mixed numbers. You'll just subtract the whole numbers and bring down the fraction part. So if the fraction is on the top, that makes it way easier, right? Because that's the same as saying I have 0/5. So it would be 2 minus 0 is 2. You can just bring it down like that. Same thing here, 3 3/4 minus 3 is the same as saying I have 0/4, right? 3 minus 0 is 3/4. So it just comes straight down, and that 0, you don't need to write the 0. Okay, where the problem lies is whenever you have the fraction in the bottom number, you can't just bring it down for subtraction. That only works if it's on the top. Okay? If it's on the bottom, then it's a whole different ballgame. I'll show you one of those after this. Sometimes we're going to have to borrow. And if you have the fraction on the second number, that's one of those times that you'll have to borrow. There are 2 ways to do this. I prefer borrowing. Some people like making them into improper fractions. So this one, this happens when the fraction part of the first number is less than the fraction part of the second number. So what I always do is I make my common denominator first to decide if I have to borrow or not. So 5 and 7. So if I count by sevens, I got 7, 14, 21, 28, 35. 35 is the first number I come to that 5 also goes into. I'm going to times 7 here to get 14. I'm going to times 5 here to get 30. Here's where I see that the fractional part is smaller on the top than it is on the bottom, so I have to borrow one whole. There's two ways to do this. You're borrowing a whole, so the whole 7 becomes now a 6. You can show that whole as one whole here, or 35, you can add 35 35ths, because that's also one whole to the 14. 35 times 1 is 35, plus 14 would be 49 over 35, and this is still 30. So the other thing I was talking about is when I borrow that one whole, you make one whole out of the denominator that you already have. That's the one whole, and you would just add it to the 14 35ths, and you get the same thing I got, 49 over 35. I like the one whole here. Some people like it this way. Now I can subtract. 49 minus 13 is 19, 35 stays the same, and 6 minus 4 is 2, and that is in simplest form. Some people like to change them into improper fractions, so this would be 35 plus 2 would be 37 over 5, minus 28 plus 6 would be 34 over 7. And then when you make your 35, I don't like this way because some of the numbers just get too big, times 7. 37 times 7 would be 259 times 5, and this would be 170. And when you subtract it, you'll get 89 over 35, and then you have to see how many times 35 goes into 89. That'll be 70, and there would be 19 left over. So that's option 2. Whichever one you prefer for borrowing is fine with me. Okay, flip it over. Here we have to borrow from the whole number to get a fractional part. So here's the one I told you about where the fraction is in the bottom number. So I have 7 minus 4 and 6/7. You cannot just bring this down because this is the same as saying I have 0/7. And you can't do 0 minus 6 in the fraction part because of the whole numbers. So we need to borrow one. So we're going to borrow one whole from the 7. There's my one whole. 7 times 1 is 7, plus 0 is 7. There's your 7/7. 7 minus 6 is 1. 6 minus 4 is 2. Okay? So your 7/7 is what you're going to put in here. And you don't have to write that 0/7. I just need you to know that that's what it is there whenever it's blank. 9 minus 3 and 4/5. So remember, that's like a 0/5, okay? Keep the denominators the same. Since that top one's smaller, I'm going to borrow one whole. That one whole that you borrow is the same as 5/5, okay? So this is no longer here, it's now 5/5. Or you could put the 1 here and say 5 times 1 is 5, plus 0 is 5. Same thing. 5 minus 4 is 1/5. 8 minus 3 is 5. Okay? All right. So these next ones are some practice problems. Might be a good idea to hit pause, try some, and then check your work. So I would do the problems and then unpause and go ahead and check. You can even fast forward till you get to the answers for each one to see if you did it right. If you did not, then rewind back and see what I did so you can work it step by step. All right, these first two have common denominators, so I don't have to worry about changing the denominator. 3 minus 1, that is 2. 4 on the bottom, 7 minus 3 is 4, and I will get 4 and 1/2 when I reduce. When I add the top numbers, I get 8 plus 2 is 10. The bottom stays the same. 9 goes in one time with 1 left over. All right, my 9/16 minus my 1/4, I need common denominators. 16 is the first multiple of 16, and 4 happens to go into that, so I'm going to make them 16ths. Since I didn't change the bottom number here, I don't change the top. We're going to times 4 to get 4. 9 minus 4 is 5. 16 stays the same. 5 and 2/7. minus 2 3/8. All right, I'm going to make a common denominator of 56 here. That would be times 8. That's 16. That's times 7, which is 21. Looks like I have to borrow. So I'm going to borrow 1. That's my whole 1. 56 times 1 is 56. 56 plus 16 is 72 over 56. Now I'm going to subtract my 72 minus 21, and I'm going to get 51 over 56. 4 minus 2 is 2, and I don't believe that I can reduce that. 5 minus 2 1/3. Okay? This is like having a 0/3. So when you borrow that 1 whole, that 3/3 is going to go there. So you don't have to write the 0/3, but if it's helpful to you, you can, if you need to write it like that. 3 minus 1 is 2/3, and 4 minus 2 is 2. 5 2/7 minus 3 3/8. Another 56 times 8 is going to give me 16, times 7 is going to give me 21. That seems awfully similar, doesn't it? So when I borrow that 1, I'm going to get 72 over 56 again. 72 minus 21 is 51 over 56. The only difference on this problem is 4 minus 3 is 1. 3/7 plus 2/5. 35 is going to be my common denominator. I times 5 to get the new top, times 3, that'll give me 6 on the top. When I add this, I get, oops, why did I times 3? Sorry, times 7. That is 14. So now I have 15 plus 14 is 29 over 35, and that is in simplest form already. 1 1/4 plus 3/8. We need common denominators. Start counting by 8s, and 8 is the biggest number, or I'm sorry, the smallest number that can go into both. Times 2 is 2. So 2 plus 3 is 5, and bring down that 1.